My name is Lynn, and this is my mini lesson about independent and dependent variables. But before we talk about what independent and dependent variables are specifically, I'm going to ask you, who likes baking?
Me.
Okay. And I assume because you like baking, you like cookies?
Yes.
Of course. All right. So let's do, because baking is a little bit like science, let's do an experiment with baking. Let's say you find a new recipe and you get it and you look at it and it says the water, sugar, eggs, flour, everything else you would need in a baking recipe, and at the very end it says add chocolate chips, M&Ms, or nuts. So which one do you add? Not like you personally, but let's say you wonder, does this recipe actually go better with one of these ingredients? Is it more of a chocolate chip recipe? Or is it better suited for the consistency of nuts? So how would you go about deciding this? Would you take all the ingredients, put them in the bowl and stir them up and hand people cookies and tell them which ingredient tastes better?
No.
What would you do?
You test them each one by one.
Okay, so you would take one batch of cookie dough, separate it into 3 parts, and then put
Each one gets a different
Yes, each one gets a different ingredient. Okay, so you have your bowl of cookie dough, or of dough, because it's not cookie dough yet. You have your M&Ms, you have your chocolate chips, and you have your nuts. Now it's important that you use the same batch of dough because then nothing else in the recipe is different except the ingredients you put in. So then you get your cookies. For each batter. Now, when you want people to test them, what would you do? Would I come up to you and give you a chocolate chip and give you a M&M? No, because you haven't tasted the other cookies. So you can say, yeah, this cookie's great, but you can't compare it to the other cookies. How would you test this?
Give one type of cookie to each person, and so they
Okay.
have to test all 3.
All right, so everyone that you give your cookies to, your friends or family, they would each get one of each type of cookie. Now, would you just ask them, do you like these cookies? Because if people gave me 3 cookies, they'd be like, yes, they're cookies, they're great, I love cookies. How would you get people to determine which cookie was actually best?
Rank them?
Yeah. So for the purpose of this, 3 will be best, and 1 will be worst. So you've got your cookie dough, they're baked, people eat the cookies, they rank your cookies. Now is when we get into the science part with dependent and independent variables. Independent variables are variables you set at the beginning of the experiment. Everything else, your cookie dough, is the same. Your independent variable is your ingredients. It is the only thing that changed between the batch of cookies that you give to people. Your dependent variable is how people feel about the cookies, about the ranking of the cookies. It's what you're measuring, it's what you're trying to find out from the experiment. It's your what. It's the answer you're basically looking for. Now, in science, or in general, you plot variables on graphs because that tells you a direct relationship between your dependent, which is on your x. One of them is on the x, and the other one is on the y-axis. And for this, the dependent variable, the independent variable, M&Ms will be on your x-axis. M&Ms, chocolate chips, and nuts will be on the x-axis. And your independent variable, or your dependent variable of the rankings are going to be on your y-axis. Okay, so for the results, let's say everyone liked M&Ms and they got 3s. And chocolate chips, nuts are great and they got 1s, and nuts was in the middle. Now, so this tells you that from varying ingredients, you can get an answer. You can find the dependent variable from varying the independent variable because they have to be directly related. You couldn't have taken the cookie dough and then baked it and then just given the raw dough to people. Or, I mean, you have to make sure they're relatable. You just couldn't have handed people M&Ms and then a cookie and be like, what tastes good? They have to be in the cookie and part of the experiment. Okay, so there are plenty of things that can be independent, dependent variables. Temperature is a really good example of something that can be an independent variable because you can change the temperature. Temperature can be both. You can change the temperature at the beginning of the experiment to determine, say, how fast ice melts. Or you can put something, or temperature can be the final thing you're measuring, like, I'm going to heat this for 5 minutes. How hot is it? Can you think of other examples?
Humidity?
Okay, that's a good one. Let me give you a scenario, and this time you design an experiment. Let's say you go out to your yard and you find acorns. And you decide, I'm going to grow baby trees from these acorns. What are some things that would be independent variables that you could alter to change their growth conditions?
The amount of sunlight they get?
Yeah, you could keep some in a sunny place, some in a shadow place. What's another thing?
How often you water them.
Water. Any more?
What you plant them in?
Yeah, soil consistency. You can have like really acidic soil or really dry soil, really wet soil. So those are all really good examples of what independent variables would be. They would be like the ingredients in your cookies, or they would be something you changed at the beginning of the experiment. And what would be your dependent variable? You change the independent variables at the beginning to find out what with the plants.
How tall they get.
Yeah, like maybe how fast they grow, like do they all hit 5 meters? Like is it simple yes or no, or just total height, or time it takes them to grow a certain height. I mean, there's a couple ways you could do it, but you have the idea. Okay, so because we finished talking about plants, we are going to do a share about photosynthesis. So move the boards. Okay. So, okay, you can't really see it, but I wrote the words on the board, and I will do the cheer first, and then we will do the cheer together. And the words are here, so you will not get lost. Okay. Quickly too. In photosynthesis, plants need sun, carbon dioxide to make oxygen. Plants need the sun to make oxygen. Plants need the sun to make oxygen. Yay! And you repeat the last line twice. I didn't write it twice, but it goes twice. Claps are optional.
Okay.
All right, do you want to try it with me?
Yes.
Yes. Okay. We'll do it a little bit slower first. In photosynthesis, plants need sun, carbon dioxide to make oxygen. Plants need the sun to make oxygen. Plants need the sun to make oxygen. Yay! Okay, do you want to try it like fast and loud?
Yes.
Okay. All right.
In photosynthesis, plants need sun, carbon dioxide to make oxygen. Plants need the sun to make oxygen. Plants need the sun to make oxygen.
Yay! Thank you for being a great class and participating in my mini lecture. Bye.